while he's talking. It's like just
Everyone, I have a bell.
she's not afraid to use it.
Grab some food and beers and have a seat and get started. I like this.
No, that's your spot, Shaq.
On the mat. Do you want a beanbag? Would you like a beanbag?
I think that's essential.
Therapeutic.
Do you prefer like a stand or something? No, you
It
do.
could become that sort of session.
It is recording.
Right.
So if you do kind of stick on that pink mat thing if you want, or you can stay here.
Right.
What's the stage? Brown glass with brown M&Ms.
I have done that for someone. Okay, cool. You don't start yet. You can sit down and like a little bit if you like.
You have to be introduced.
You've already set up the AV for me, so you can introduce yourself if you want. There's seats here, but that is also close to the food, so. Hi everyone. Anyone's first time at CTO School? Awesome. Why?
As in, why am I here? Should I leave?
Welcome to, for those who it is the first time, welcome. Glad to have you here. Unfortunately, you're stuck with just me for today. Usually Chris MCs, and Louis is the other organizer there. Thanks for coming. And just some housekeeping that I have to say. The toilets are past the lifts, and ladies on the right, men on the left. The fire exit is also near those, so if things are on fire, please leave. And
How to get out?
I love this every time. Getting out of the building is really, really difficult. Because, so when you walk from the lifts to the glass doors, there is a pole about halfway up, 10 meters that way, with a green button on it. Super intuitive. You need to hit that button, and the doors won't open until you walk towards them. So that's how you get out. Otherwise, just ask someone to help you find your way out. Thank you so much to Tim and ThoughtWorks for hosting, as always. And the beer and the food, the amazing, delicious food tonight is on them, as it is every month. And yeah. So let's start off with some announcements. CTO Summit is coming up very, very soon. And their speakers are going to be announced hopefully by the end of this week, if not early next week. There's a really exciting keynote speaker, which I don't know if I'm allowed to talk about. And
Wait, don't tell anyone.
I'm recording myself, so I've dug a hole here. And there is a 25% discount for CTO School folks, which I've just posted on meetup.com. It's really just a code that anyone can use. Feel free to use it. And any other announcements? Sorry, out to them. Any events coming up? Anything you want to spruik?
Sold out. there's no point. There's a really good development conference coming up. It's community events on the 1st of December, but you can't come if you haven't already got a ticket. Yeah, DoD Brisbane is coming up, but fully sold out. There are some sponsors that we're giving away some tickets soon, and there may even be some in this room that you could talk to.
This
Sure launched a product.
Sure launched a product!
Yeah.
Yeah, that was a good one.
Tell us about your product, Sure.
No one signed up.
They haven't told us all about it.
It's all over Twitter. It's a lease management platform for companies that have leases. It's very unexciting for those who don't have leases. But for me, it was exciting to launch. So, thank you.
Congratulations.
wasn't expecting that.
What else? There was something I was trying to remember. There's a hackathon coming up. Is it past?
2 this weekend.
There's 2 this weekend.
Energy Lab Hackathon.
And that one, the Internet Freedom Hackathon. And
There's another one next weekend.
yes.
Which I can't remember what it's
I
called.
don't even know about it. Cool. If you Google an Internet Hackathon in Brisbane, maybe you'll find it. And this is, most importantly, this is the last CTO school for the year. Sadly, it's been an amazing year. I think there is a huge meetup user group party coming up that's usually at Grand Central Station. That is just all the meetups combined. I think probably most of you know about it, but if you don't, there will be drinks at a place somewhere next month. And I'll let you all know about it. Okay, without further ado, Mr. Shea. I had a bit more than that, but not much more.
Sorry.
Okay, you can do yourself, great.
Sweet. Leaving that on. Okay. So thanks for coming out, everyone. It's kind of a group therapy session, so I want to keep this as conversational as possible. Feel free to jump in anytime, share any stories or correlations between stuff. I've always worked in a very Microsoft-centric stack. I don't know what the audience's varieties of technologies are, so when I get to some of those slides and stuff, feel free to share what kinds of things you work on and how you do stuff. So, who here writes code on a day-to-day basis? Cool, we're mostly code-ish kind of people. Good to know. Shh.
She's supposed to write code on the day.
Not many.
So how long has it been since that code hit production? Is it more of a hobby or is it like day-to-day kind of stuff? Half an hour this week,
This week.
recently?
Sweet.
Cool, awesome. So just to introduce myself, my name's Shea. I've been in Brisbane for quite a long time. Spent quite a few years as a software architect at a place on the Gold Coast. Many years as a junior before that, being blissfully ignorant and unaware of all the terribleness and scary things that are software development. Spent 8 years as a consultant at Redify, traveling around and visiting all kinds of different places, companies, industries, and sampling all the goodness and badness that is out there. And for the last 3 years, I've been CTO at Oztix, a few of the audience members here. So tonight, I was asked to come and do a few talks, and I thought I could look back and try and analyse, of the last 16 years of different software projects and different things, what kind of stuff worked well, what didn't work well, try and have a bit of a retrospective and introspective of those kinds of different projects, and try and put a thumb on all the gut feelings of why did this one work, why didn't this one work, what were the challenges and those kinds of things. So the journey tonight is having a look a bit back at the past of software and then taking a look at where software is as an industry now, having a look at the different people involved and how that plays part, and then taking a look at where we can take more focus and spend better of our time in our day-to-day. So a look back at the past. So everyone loves to compare software against buildings, so I thought, why fight it? Let's just go with that. So physical architecture and the way people build things has been around for a really, really long time. They've had thousands of years to get this stuff right. They've tried numerous different things and they've failed in spectacular ways. Some cultures kind of stuck with their ways and kind of wrote it out until they ceased as a culture. But they've had a long time to trial many different processes, designs, materials, come up with new materials and try many different things. Software, however, is extremely new. We're still in basically the first human generation of software. It's only really been around for kind of 70 years, so none of us really know how it's done yet. We're all still trying to figure it out. So we're kind of way back in that physical architecture period of, we're basically in that Egyptian space of we're chiseling stones, we're slave labouring our way through this stuff, we're doing it the hard way, pulling rocks up hills and stacking blocks to form very useless and large but very beautiful structures that are not very usable, and inside there's not much space. It's not really the best way to kind of put this stuff together. So it's still really young. We've been going for only 70 years. So we're still learning, and yeah, no one really knows how we build software yet. Everyone's still trying to figure this kind of stuff out. So the status quo. So again, this is probably more of an audience thing of who out there started straight out of uni into a particular kind of job with a certain programming paradigm. So what I mean by that is, if you came out of uni and you were doing a very like C or Java or anything like that, we're in that very procedural space. Started off in that kind of world, very procedural. Anyone lucky enough to go straight into some kind of functional or other kind of paradigm out of the gates? No? Yeah. Okay, so a long time ago, many of these languages in the very early days of software development kind of came out of this very fertile period, a very long time ago, of no one really knew what software was or how to interact with computers or how to construct this kind of stuff. So a lot of people kind of went off and came up with a lot of ideas and theories and styles about how they could do programming and put software together and interact with all their computers. So sadly, a lot of us, by the looks of the audience, we all kind of jumped straight into one particular paradigm, and we never really got exposed to a lot of the other ways that we can put software together. And given how long ago a lot of these paradigms came out in the 60s and the 50s even, we're still kind of doing stuff the same way today, and a lot of us haven't really had the opportunity or maybe the desire to look across and try a different technology or a different way of thinking and constructing software. And again, we're still trying to figure this stuff out. None of this stuff's set in stone. We're all learning. Does anyone in their particular language straight out of uni kind of stayed in that, already know the answer to that. So everyone's kind of stayed in their vertical of their particular language. Does anyone try different languages in that vertical? Anyone come out into like C and then try .NET, Java, and a lot of the other stuff in that kind of same vertical? Yeah, most of us. Cool. So again, we've been doing software the same way for kind of 70 years, and nothing's really changed. We've got this big ball of mutable state somewhere behind a server. We're running in these particular language constructs. We take in commands, we execute that, we mutate that state, and rinse and repeat. Over time, it slowly mutates and changes over time. So nothing's really changed much in that particular time. But computers themselves have changed quite a lot since then. So back then, there was sort of one CPU, one block of memory. The way that you interacted with that one CPU and that one block of memory was kind of the same. These days, however, most PCs have multiple cores, and even worse than that, there's massive nodes of cloud and thousands of nodes. But we still write software in that kind of same way. We haven't really changed much since then. Speaks for itself. Just because we've always done it that way, does that mean we have to keep doing it that way? The same old kind of thinking generates the same kind of results. And again, we're all pretty new as an industry. We don't really have this stuff figured out yet. We're all kind of learning. A lot of massive software companies out there are trying to figure this stuff out. Googles and Netflixes and all those kinds of companies in the world are really trying to try different ways of solving problems. Some kind of stick with their stack and build very large ecosystems of frameworks and tooling to try and control a lot of those things that start coming out by sticking to those paradigms. So how can we address that? Largely us. Everyone coming out to these kinds of things, trying to learn more, trying to think different, trying to try different ways to doing things. And having come from a consulting background, I guess the best part of living in that kind of space is you get to move around a lot. You get to see lots of different teams, lots of different tech stacks, lots of different technologies, sometimes lots of different languages. If you're lucky, you get to try a few different kind of paradigms as well. And you learn a lot in a very condensed period of time if you're lucky enough to move around. And because there's so much going on and so much learning, a lot of our industry and a lot of us suffer from something known as imposter syndrome, where we never really feel like we know what we're doing. We all suffer from it. I don't think I've ever really met anyone or seen anyone out in the wild where there's not aspects of this, because everything's moving so fast and you never really feel like you know exactly how to master this particular thing. A lot of us kind of question what we're doing and never really sure. And that's because we're all on a learning journey, because nothing is concrete. Everything's always changing. Nothing always feels like the right solution to a particular problem. We're always looking for better ways to improve and other ways to solve a lot of those kinds of problems. But that's also the most exciting part about coming into this, is we don't really know what we're doing, but it's always fresh. We're always learning something new. We're always trying something different. And you kind of go on this valley of learning where you realize something's not right. So you start trying something, and then you realize you really don't know how to use that thing. So you go into that pit of despair of, crap, maybe this isn't right. And you kind of revert back to your old ways. Or sometimes you stick to it and you learn. You come back up to that peak of, yes, this is working great. And then you hit that plateau of, no, I've hit the boundaries of how I can make this whole work for me. And then you start looking for the next thing. So a company a long time ago, 98 in this case, they were a software consulting shop. They noticed a lot of this stuff as well, but I guess they were looking at it from a different perspective in that they went out to a lot of places. They tried to instigate change, try and teach people of better and other ways to solve problems, but they found that when they left, people would revert back to the way they were doing things before. And I don't think I can't actually think of a time consulting where once leaving, it really did stick with people. And it was always that weird feeling of, why is that? And it's an interesting exercise to think back to all the projects, teams, products and things you've worked on over the years where something new was introduced and why didn't it stick? And it's a very interesting exercise I recommend everyone goes through of, why is that? And that was the hardest part about coming up with this talk, is trying to take all those gut feelings and unknowns of why did that work, why didn't that work, and try and pin that back to someone else's research or names for this stuff. So this paper was interesting in that they tried to pull it apart and they tried to identify why is that. They talked with all their clients, they went out and consulted with a whole bunch of other consulting companies to find out if it was just them, if it was everyone. Turns out it was everyone. So they pulled it apart and tried to dissect it into different things and reasons why this kind of stuff wasn't sticking. One of the big proponents of this kind of stuff, we're not really going to talk about today, but a large amount of it was due to management and the way that people were chasing deadlines and stuff. You tried to do a new thing to fix a thing, you'd get whipped in line like, why aren't you coding? Why aren't you typing? Why can't I see screens? And a lot of it was management related. I don't know if we've all experienced that kind of stuff where you're doing something some way and you know there's probably a better way of doing it. You sort of start going down that road and quickly get management putting you back in a line to get that stuff out screen by screen for next week. Yeah, so I mean that was a major part of the factors, but that wasn't all that was wrong. People don't like change. That's pretty universal. Change is hard. Change is scary. We're so young as an industry that change is inevitable, and I guess we have to embrace that. So we have to find better ways of managing change ourselves internally. And they sort of pulled apart how people learn stuff, why they fear change, why this learning curve is the way that it is. And this was one of the main factors they found was the reason why people did revert back to the traditional things that they're familiar with, they're happy with, they kind of just keep plodding along doing the same kinds of things. And that was how that people absorb and then apply their different learning techniques and technologies and other different theories. So there's 7 stages that the report outlines. It's very eerily similar to this, where you start off as that kind of innocent little victim on the left, where everything's awesome and it's all great. And then someone comes along and shows you how bad things really are, and you start realizing that I've got to spend all this effort and training and stuff, and it gets worse over time. You end up basically half human, half robot, lots of scars, lots of bad things. But you know your stuff. So the stage one of this kind of thing is the innocent, right? You may have heard some stuff, you may have heard that things could be better, but you're kind of blissfully unaware, plodding along, doing your thing. I don't know if anyone's familiar with the frog and the pan analogy, where apparently, again, I don't know if this is science or just a story, so
You haven't tried yet.
if you put a frog in boiling water, it jumps straight out. But if you put it in and slowly increase the heat over time, it will boil to death. So the innocent is that kind of frog in the pan, doesn't know what's going on, things are getting hotter, doesn't kind of realise. And then stage two comes around, which is someone kind of lets you know that things aren't that great. Or maybe things are starting to heat up and you start looking around for maybe different ways that you can improve your current situation. You kind of maybe have heard a few buzzwords or a few different things. You start having a bit of a poke around to see what could be better. Then you move into the apprentice stage. Now, this is the just enough to be dangerous stage, where you've heard a new thing, it's super exciting, it's going to solve all your problems, it's the hammer for all your nails. Definitely blockchain. No, he's not here. So the stage three, they've been introduced to a new thing, they might have gone out, they've done a bit of a workshop, they've kind of taken this small but realistic, and it really looks like it's going to solve all your problems, but they've done it on the small, where you haven't really scaled it up to maybe solve your whole ecosystem's worth of problems. So, they come back with this massive excitement and maybe somewhat often unwarranted confidence that this is the answer. Now, these are the most dangerous in the learning curve, but I guess these are the people you need to nurture and drive through the different stages. I've been a stage three on almost everything ever. Okay, the practitioner is where you kind of take that excitement and unknown, and you kind of think it's going to work, but you don't know, and then some project comes along, and then you've got to apply it, and as the paper says pretty well, with the unusual demonic cocktail of politics, deadlines, and changing requirements, while you're also trying to figure out how to hold this technique, tool, product to get this done. So it's a very difficult stage, and this is the stage where most people hit that wall and kind of give up, or they hit some things and it's too hard, and they kind of bail out and just go, nah, it's not working, I'm going to go back to my tried and true, it's definitely the way, because I know how to do it. So yeah, this is the hardest one apparently to get past the stage 4 thing, where you really need to have those kinds of mentors, people who can help you out, and people who can get you past that hurdle or push you through. Again, when you come out the other end, it may not be the right choice, but if you stick to it and do it, at least you'll know why it's not the right choice, so you can make better decisions in the future. Past that hurdle point, the other 3 stages, they're kind of largely similar in that you've come out the other end, you've got some advice to offer anyone else coming through that kind of journey. Stage 6, you've kind of mastered a bit more, you understand why a bit more, like all the mechanics and a bit deeper knowledge of all that kind of stuff. And the 7s is when you get out there and start sharing the word, writing books, and also start thinking about how you can take that thing and move it to the next level. So this is that kind of curve where you kind of hit that dip between the stage 2 and 3 in terms of productivity and those kinds of things, where as you're trying to figure out how to hold it and implement it and get it out into the wild, you take a bit of a dive, and then when you kind of get past that hurdle, you kind of accelerate in terms of productivity in that particular technology or technique. And remembering that in any code base that we work on, there's typically every team member on the team has numerous versions of this curve going on at any point in time, whether it's your database technology, the way that you do web service calls, and all those kinds of different things. Everyone's got multiple layers of different learning curves at any one point in time. So you've got some people who are experts in one particular thing, but complete level 1 or 2, stage 2s in a particular other thing, where they might not realise there's a problem there. Things might be able to be better. So it's a good exercise to sit down with your team and, you know, have a go and try and self-assess where, pick apart one of your code bases and pick a lot of the technologies, tools, techniques, and other things that you're using on that code base, and try and have a pretty honest assessment of where you are on that curve. And even more so, like, where do they want to be? Do they not really want to move from that particular point? Because I guess it's not realistic to assume that everyone wants to be this, you know, level 6 master in that particular technology. They might just want to know enough to get by. So getting to that kind of stage 4, just proficient enough to do the thing. Whereas, you know, it's good to pick a few key fundamental parts of that and grow your own stage 6 people who really know that stuff, who you can go to when things are on fire, when you need to tackle a new project. How should we do this? If you've got that 6 or 7 level, you know, how could we be doing this better, and look towards how to do things better with that particular technology. And how can we apply that kind of stuff? So knowing we're all on these different learning curves, we're all at different levels on this kind of stuff, how can we trial these kinds of things? When a new project comes up, when you've evaluated a few different technologies, how can you figure out if it is a good fit for purpose? And the only real ways, after looking back at previous projects and things where, you know, multiple members of the team throw a few different ideas in the ring, typically if you try and vote on which one should we do, you'll almost never get consensus. I don't think there's ever been consensus in IT in the history of man. So the only real ways that you can try to probably tackle that, and looking back at projects that have kind of felt like this worked well, is if there's 2 main contenders in the ring, is do both, spike both, put them both through the paces, and then come out objectively at the other end and go, this one felt like it worked better, try and measure that and quantify that. And then sit down as a team, and there's, I can't remember the name of this thing, there's an architecture decision document you can put in your repo or alongside your solution, where you can actually articulate, here, this problem came up. Here are the contenders that we narrowed it down to and why. We put it through its paces. Here's why we picked this one. The other one, it's not that it wasn't good, it's that this one was a better fit for these purposes and conditions. And it also helps when someone new comes onto the team, they can look back at your previous decisions and not come in and go, wow, what is this madness? Who would ever pick this particular thing? So, again, I don't know. Has everyone felt that before? That thing. It's very good. Very, very good.
It's a ThoughtWorks invention, apparently.
What's that?
An architecture decision record.
That thing.
Lightweight architecture decision record. Oh, lightweight.
Only small.
Sounds agile.
So yeah, they're really good. And again, because if you've got new people coming in the team that can come in and just be like, what is this madness? Why did you go down this route? You know, it's always a series of trade-offs. Everything's got trade-offs. Everything's got warts. Nothing's perfect. Again, we're all new at this. Nothing's set in stone. Nothing's kind of the one true way. So it's great to do that kind of stuff. And be comfortable in the knowledge that any decision you make will be wrong, given time. If you haven't looked back at a code base from quite a while ago, even last week or today, and gone, that was great at the time, probably never going to do that ever again. Yeah, I haven't experienced that, so if you've experienced that, I'm very jealous. So knowing that none of the decisions you make will be right forever is embrace that. So if you make a decision on something, it's not set in stone. Don't hold it as dogma. You know, come back, refactor it, change the code, change your architecture decisions, and change your thought process as well. So again, coming back to the language paradigms thing, where if you know that one thing and that's all you know and you're proficient in that, you know, you can usually get anything to work. but it might not be the best way of doing it. There might be other ways. But where to do those pilots and experiments? I guess that comes into the whole premise of the talk, which is where to focus your time. So knowing a lot of the history around, we don't really know what we're doing yet. There's infinite ways of solving these problems. None of them are kind of bulletproof. All of them have trade-offs and downsides. Where should we spend that time? There's an excellent paper from '86 called No Silver Bullets, or Bullet. And it makes some pretty polarizing posits at the time, which is there is nothing coming from software to solve all your problems. There's no solution that's going to answer all your problems and solve everything. If they are saying that to you, chances are they're selling it to you. It's a product that someone's trying to sell. So Moore's Law's got this, hardware transistor line going up at a pretty steady 45 degrees, but compute power is pretty stable. But the rate in which we're producing software is definitely not on that same kind of curve. We're very much at a kind of plateau. And he predicts that there's nothing coming along in software that's going to make writing software any faster or easier. It might get a bit better, but nowhere near the curve of the compute power curve. And that's because, as he mentions in the paper, it's a conceptual problem in that the challenge in writing software is never writing the particular software in question. There's some challenges there, but the hardest part is knowing what to write, how to solve those business problems. And it kind of breaks it down into two kinds of areas. And they bucket it into this accidental complexity area, which is the things related to dev stuff, dev tools, dev languages, build pipeline, like all the plumbing and mechanical pieces and technology choices that are made that are not technically solving the business's problem. I need to do this thing and send this information to a particular person. And then there's the other half, which is the essential complexity problem, which is solving the actual business problem at hand. And as an industry, again, looking back at the last 16 years of things, trying to think of those two buckets and categories of stuff is, where do I feel on those projects we've spent majority of our time? And it's almost always in that accidental or incidental complexity, where you have endless debates and arguments, and there's dogma around this is the choice, and spend inordinate amounts of effort on the incidental, accidental complexities, which is never ultimately addressing the essential complexity problems of the business problem at hand. And we invest a really large amount of time talking about tabs versus spaces, just things that don't ultimately drive business value unless you're selling storage space or something. Let's not go into the tabs versus spaces. But yeah, we spend a really, really large amount of time discussing, arguing, and spending all of our wasted hours on the incidental. Again, there are important parts to that. It is important to do those architecture decision records. So it is worthwhile doing that. But there's clever ways that we can do that. There's intelligent ways that we can do that and measure that. Pick a few, do a few, pick one, go with it. We're all smart people in this industry typically, and that's not usually the hard part. If you pick a framework for your user interface, whether it be React or Angular or Vue, you can typically get something up and running with that relatively quickly and polished over time. That's not usually the hardest part of what we do in software. The hardest part is knowing what to put on the screen and how the user interacts with it, and the business problems and what their domain is. And we spend a lot of time in that area where I feel like we should spend more time. Again, looking back at the projects that felt like they worked really well, that were good to maintain, that when the business problem changed, you could go back and address that and change that, is those projects invested a good amount of time in modeling the domain, understanding the domain, trying to represent the domain in the most succinct way possible. They always felt like they worked, and it was better to work on, more just good in every way.
Do you think that's because people think they know an answer to the incidental ones, but they don't necessarily know an answer
So again, that absolutely that. So, you know, if this is tough and really hard, you know, it's really easy to just go and do this other thing that is actually quite easy, and you get that successful feeling like, yes, I got that screen to bind and the model matches, and yeah, like you get that reward a lot faster. Whereas
talk to the business.
the business, you are the business. But if you spend that time on the essential stuff, like that's the hard stuff.
Yeah.
That stuff never gets easier. You know, no one really wants to spend that time on that because it's not as instantly rewarding as I got that screen to go. I built some framework. I've got some plumbing to work with that. You know, you get that instant satisfaction. So yeah, absolutely that. And no one really wants to tackle that hard stuff because that is the hard stuff. And there's, as the paper posits, there's nothing coming in software that's going to make us be able to build software faster because the inherent problem is the essential complexity problem. You know, we can make optimizations in the accidental and incidental space to make it quicker to do those things. And it does get easier and it does get better. And we do get faster at those particular things. But then we get back to the essential problem and we hit the same slowdown point and it gets hard again. And then you look for other things to do because that's the hard stuff. You kind of brush that aside. And I guess any code base that I've ever kind of seen and worked on over time, again, this is my own experience, is, you know, we have these beautiful frameworks and technology things that are going on, and then you look to the right and look at the essential. It's usually a bit of a dog's breakfast of, you know, we'll just add another if statement in there, and you know, you kind of just get it going and keep it running, but you know, move away from that. You go back to the fun problems.
Build a business rules engine.
Just that. That's how Workflow Engine was born. So yeah, we chase our tails a lot. We're extremely dogmatic around the incidental stuff, and like we get in these massive debates around technology UI frameworks. And look, there's some merits to those, but if you picked any of the three main ones today, I'd be surprised if you couldn't make a good app do good things. Again, another good quote from the author of that article, which is the hardest part about building software is deciding what to build. So, lots of rambling on many different random topics. So the main part is, again, trying to take all these feelings and intangible things and try and put it down to something that we can take away from this kind of thing is how to put it all together. This is the hard bit. So we've got people and their learning journey at the top. So their expertise in whatever the thing is in question. And that's hard in its own right. And then, again, you get to that stage 3, you're kind of really excited about some different thing. You've got to get over that hurdle to learn a new thing. So we've got people on the top and their learning journey. And then we've got those incidental complexity things that we've been talking about, which is tools, frameworks, the incidental things of just putting some software together. That, again, change over time. We don't really know how to do this stuff yet. Chances are you're going to try many, many, many different ways of putting things together that will change over time. And we spend most of our time in that incidental space, which is taking our learning to a particular framework, putting that technology piece together and learning that and doing that well. And then on the right, we've got that essential problem, which is the actual business problem at hand, where you need to interface with people, find out how they operate. Find out what their problems are and solutions that we can come up with as software teams to solve those problems. And there's definitely a learning journey with that as well, because there's different techniques, there's different styles, there's event styling, there's all kinds of different things you can do to try and elicit and uncover and understand those problems. Because like us, business people don't know what they want either. You know, if you ask them, what do you need? They're going to give you some pretty crazy stuff that you have to unpack, come up with some tools and techniques to try and get down to the real problem at hand. What is your actual problem so we can come up with some solutions? Because typically people come to you with solutions, not problems. So we can spend a lot more time in that space to find our domain better. And also we can come up with better ways at representing our domains. and this probably ties back to the paradigms slide and different languages and different paradigms and ways of doing things, is there's often probably a way more expressive way that you can represent your domain, something that better controls how it functions, what the rules are. Again, coming from that procedural kind of space where C# is kind of our kind of world, a lot of things are quite hard to represent in C#. When you go outside of your box and you start looking at other languages and things, a lot of those become a lot easier to represent. They come with their own challenges, obviously, because you're at stage 2 to 3 in the functional programming space of how do I do that? How do I get over that learning curve? But it's definitely worthwhile to take that time, do some spikes, try out some different things and better ways that you might be able to represent that particular problem domain, because that is the most important part of what you're building. As professionals in this space, we mostly only have jobs, unless people are writing frameworks, is to solve business problems. That's why we exist. We exist to serve a function. And that's the most important part. Again, this stuff's really important as well. The tech is important, but we can be clever and smart and measured about how we choose a few different types of technologies, put them to their paces, build a full slice in that particular technology and measure what worked and what didn't work. So as a business, they owe it to us and we owe it to ourselves to invest the time to trial at least 2 to 3 ways of doing something. When most businesses go out to tender, they typically go out to multiple companies who come back with proposals, and then usually it's the cheapest one, or I love that, different problem. You should pick it on merit or objectiveness of a measured approach to that is the right solution for our problem. But you won't really know that unless you actually try the 2 or 3. So you need to kind of, I guess, as people in the leadership field, is make that time. Try and get them to understand that if we make a decision or we make it wrong, we have to go back and revisit it again. We might not know all the problems. So I don't know if that makes sense there. I was, again, trying to look back at 16 years of different software projects, of what feels like it worked, what doesn't feel like it worked. The ones that succeeded, that really did deliver good business value, that felt good to work on, and like they were achieving their goals and actually satisfying some kinds of needs, and could actually pivot and adjust to a changing business requirement. Felt like the ones where you spent the most time understanding the domain, investing in the domain, making that first class. The technology part was usually just pick 2, chuck it out there, let's give 2 spikes on either of those, evaluate each of those on its own merits, pick one, knowing that whatever decision you make will be the wrong decision. Go with it, learn it, try it, put it through its paces. You'll build up some stage 6s and things in your team to know, well, they're the expert on that particular platform and technology, but they'll also know the trade-offs, they'll know the warts, they'll know where it doesn't work, where it does fall over. So yeah, that's my experience of trying to pull apart many years of different kinds of projects and trying to put it into words and then say words at people. Good fun. And again, as an industry, if you ask for budget time and project time for this stuff, you'll ultimately get no, because you need to be shipping shit, you need to be pushing buttons on a keyboard, because, that's why we're employed, right? We're employed to type. No, we're not employed to type. It takes way more time to think, talk, and elicit what the problem is, and very little time to code that up and put that together and get that out into someone's hands. So it's not about having time, you've got to make that time. You've got to push for that time and push for that budget in the project, because it's in everyone's best interests. Everyone's on a learning journey, everything's always changing, nothing's guaranteed. We're in that first generation of software people. Someone who started when software first started is likely to still be alive today, compare that with any other kinds of industry. There's been thousands of years of progress, development, trials, failures, changes over time. We are very, very young. Nothing's really set in stone yet. So having that growth mindset, not fixed mindset, where you every now and then it's worthwhile to go out of your comfort zone, try a different thing. Focus on the essential, not the incidental. And again, develop the experience on finding the essential. And I know it's not for everyone. It is hard. But as software engineers, I guess typically in the past, it's been very much painted as something where you can just sit in the corner and type on a keyboard and not really interface with people. I guess that's really important to grow and establish those skills and progress that kind of staged learning curve of getting to that stage 4 where you're comfortable with that kind of thing. Spend less time on the incidental. Trial things, experiment, measure, do things in smart ways. Be pragmatic, not dogmatic, because you'll be wrong at some point. Thanks for sticking around. Again, this is very conversational. I'd love to hear other thoughts. Again, because we all work in different sectors, it feels like, and different kind of languages and different things. It'd be interesting to hear other people's experiences in other spaces. So attending other kinds of functional programming, like going outside of your paradigm, attending other user groups of different languages, you hear different kinds of problems, but there feels like there's still that same shared problem where there's a lot of technical bits and pieces and mechanical stuff that people are struggling with, but everyone always comes back to struggling with that domain problem. Some particular languages and paradigms don't suffer as much as expressing the domain, and you can kind of hear that when talking with those. So I'd really love to hear other people's experiences and things if they've worked in different tech stacks and other industries and languages. I'd love to hear your thoughts and opinions on all the words that were spread in your general direction. There's a few different reading things. I'll share these slides. It's just up on GitHub. So I'll share some of this stuff, a lot of the readings and things, that kind of stuff. Some excellent watching. Those first two should be almost mandatory for anyone in the technology industry to watch. It really does challenge a lot of the status quos and gets you to think a little differently. Interesting stuff. So I'll share this stuff around afterwards. Please do at least watch the first two. I implore you to watch just those two, if anything. Watch them on 2-speed. Sometimes the speaking is a bit funny and double speed, but you get through it a bit quicker. So thank you. Any questions or just bust into general conversation?
I don't know how I'm going to articulate this question very well, but when you started talking about the incidental, it feels like because technology itself is exponentially growing, but you're saying software is linear, because a problem or a domain might exist for a number of years, you end up with legacy and technical debt. So doesn't the incidental then become the essential? At what point? Like, do you feel there is a crossover?
To a degree, and that's why it is important to try and make the best decision at the time, but I guess it's not always got a very long tenure of whatever decision you make. If you make good measured decisions, they will tend to last a little longer, but I guess at some point they're probably going to start not matching. So like if you built and designed a system to run on your own hardware a few years ago, it works well on 4. And then all of a sudden you blow out to an auto scale stack of 60. The ways that we've been writing software in the past, going back to we've been doing global state mutation via simple procedural calls for such a long time. We don't have a really good solution to, we've got 80 nodes now trying to fight and try and access that shared state and mutate it and do those kinds of things. So that gets really complex. You did the best up front by making a good measured decision there, but things changed. The world moved around us. It does okay, but it doesn't some changes need to be made to go to that next evolution. There's some pretty good quotes out there where we don't build software, we should grow software, in that it's always evolutionary. So you start with one thing and it's great at the time, but you need to kind of evolve it in stages over time. Sometimes completely obsolete it by replacing the thing, but it's usually best to evolve that over time. I don't know if that helps at all.
Well,
It's tough.
Yeah, it's an answer, and it feels like you do have to spend some investment in tech debt and in incidental to make it grow. Otherwise, you are left with legacy that you have to replace.
Yeah, so it's good to make that measured decision up front to try and get the best distance out of that decision, but knowing that it does at some point become obsolete, become legacy, and then it's the approach of like knowing that that's going to happen and embracing refactoring, both the code and your architectural decisions and thought patterns, even where maybe this language doesn't represent what we're doing very well, maybe this other thing does, and not being too scared, I guess, to venture outside of our linear thought thing of, well, I do things procedurally. That's the only thing I know.
I think where that legacy problem goes wrong is when it's A pass that's used by well and true pass that's used by date, and then you'll get the team of people tasked with replacing that. They don't want to go and have the tough business conversations. It's like, well, you're telling me that you built it wrong 10 years ago. And so it's like, it just has to do everything this does, but better or faster or cheaper or whatever it is. And so it stops being about that implicit complexity again and just becomes a tech problem. And then it's like, oh, we'll use these tools. And again, the actual business problem that needs to be solved today gets completely ignored, and you end up just, ham-fistedly.
And I guess that's probably a whole other talk in itself. Is you make those decisions.
Yeah, completely hypothetical story that one.
Make those decisions up front. Like, when is a good time to pivot? When is a good time to change? And I guess that's very it's dependency kind of.
And management aren't usually that time.
No, and again, that's that coming back to we need to make time. We need to help educate people that we did make a decision, and we're at this part in software evolution. This stuff's changing rapidly and will continue to do so for probably quite a long time. What's our investment strategy in tackling that? Of come along and health check that in 6 months and go, ooh, this is not really working well anymore. We might need to put some investment in to try and evolve it.
It seems to me from a product side that both those things are correct. On the one hand, the essential business stuff is really important because if you get that right the first time, whatever technology you use is going to last a lot longer.
Yeah.
If Word didn't need to keep changing its functionality because it did what it did originally, which was what a typewriter did effectively, you don't need to change it unless something else happens. But the other side is also correct that I think there needs to be massive education of the upper end of the business that things need to change. The technology is changing faster than we're changing our business requirements. So our business requirements might be the same in 10 years' time, but the technology is going to be different. So what we built 10 years ago is not going to work. And I think, so both of those are really, really important.
Yeah.
If you get the first one right, you have longer to make the changes.
Yeah.
But if you need to be spending that time making changes and educating the business.
And again, the anecdotal thing of something that I've experienced is, we worked on a product a long time ago that we built and spent a long time on the business domain side of things. That thing's still ticking along nearly 10 years later without a development team. Again, it's not the technology part per se, but every couple of years you'd come back, like, oh, I've got to change this thing. You'd come back in, not having seen it for a very long time, but because I guess the domain was quite invested in, it made sense to a degree. But you could work on it. Whereas if you like a lot of the code bases, you sort of don't really focus on that stuff. You focus more on the technical. If you came back in a few years' time, you'd have no idea what was going on in the business. Like if someone asked you, what does this do? There is almost no way you could answer that question. Sorry.
How baby grew up.
Yeah. So again, that was just coming back to thinking back to projects and trying to put a finger on what was it about that? And it was the heart of it, and the business domain part of that was nurtured. It got much more significant investment than that incidental part where it's like, yeah, we'll just pick this thing, build that, yep, works, cool, solved. Go back to the business problem, spend all that time in there. And if you came back today, you could but you could almost take that heart of the business domain of it and its representation of that and kind of just take away the framework side of things, plug in a new incidental complexity problem on top of it, and possibly have good returns from that.
I'm sure everyone else has encountered this too, but in web, a lot of the time the business domain is changing faster than technology is, and that presents its own set of problems where you're starting to get to business domain problems where your tech stack, which was perfect for the business domain and isn't that old and is still valid and current, still can't handle the new business requirements that come in.
Yeah, I guess there's some interesting spaces where if your business is technology, that's its own whole unique kind of minefield where, because it is changing and evolving so fast, you know, not only have you to pick a technology that's going to obsolete itself in a very short amount of time, that's also the business space as well, where you kind of tie to the inevitable obsoleteness of that particular technology. That's a really tough space to be in because technology does move so fast. If that is your business, it's a really risky business, and I guess that's where a lot of the big tech giants come and go in a very short few year kind of window compared to your normal bricks and mortars kind of businesses where their business domain and their business problem is largely safe. It changes a little bit how you get access to it, but it's fairly stable in itself. But yeah, that's got its own fun challenges.
You said make time and you have to educate management. How often have you successfully done that?
With great difficulty. Look, it's usually done via sneak in it kind of, you just kind of say one thing over here, but you know what you need to do to get it done. And look, that's really hard to do. And when it doesn't pay off, there's some really difficult conversations that are had. But more often than not, it kind of works out well because you've invested in that right kind of area. It's a really tough one to answer that because like a lot of consulting work over the years, and again, looking back at the ones that worked and succeeded was usually despite what the management was projecting down at the team. It's kind of you formed that bubble over that because you knew where and how you needed to do that focus, and then you did it anyway. And be damned to the management coming down telling you what to do. Again, it depends on the management scheme over the top of the team, how insulated that is, how you can just get on with it and get it done. But again, that's very challenging. Again, that's probably some of the managers that came along for that journey learned a lot and went, you guys ignored me and still did it anyway. Thank you. But a lot of them, not the case as well. But I guess that's the other challenge is the management understanding of technology in itself. So I guess that's why at the start of the talk I asked how many of us in the room still code today, experience the pain and the challenges that come with building software. So I guess it's really hard to have a management who doesn't have a little bit of empathy or sympathy at least of the plight of software and the challenges that faced with an ever-moving, ever-changing kind of landscape. It's really hard to project that upwards unless you've got someone who can sympathise at a minimum, but empathise hopefully.
It's beautiful chicken and egg trying to do that transparently, where you need trust to be able to have that conversation successfully, but you don't get trust walking in on day one. You earn trust over time, but it's on day one that you need to be investing in that essential and incidental.
So usually you take a few on the chin to start with, build a bit of that trust up, and then do a few of the harder things. So again, it depends on the environment, but largely the times I've seen it work really well is where you kind of just did it anyway. And that's tough because you have to have the right kind of team, the right kind of environment to actually pull that off. Everyone needs to be invested and want to succeed, where I guess if you've got the wrong kind of team around you to do that, you'll take that on and say, no, I'm not doing it that way, and then just do terrible things. That's never really going to work. So it's very cool.
If you want the trust on day one, you call yourself a consultant and up your rate by 10 times.
Even with that.
But it is tough.
The more you cost, the more they'll listen to you. You just trust that
The better the
you're
lawyers.
doing.
And it is tough because, you usually have to come in and sort of do the things you know don't work for long enough to hopefully educate them that there are better ways if you can build that trust up and then take the whole, hey, how about for this next one, we try it this way and measure the results afterwards.
If you've got a team of the right people, but you need enough of them, you get some people working on the quick wins to help build that trust, while the other people.
If you can insulate the bubble and maybe
quietly.
break off to the
Yeah.
it's really hard to try and do if you've got the wrong kind of management on top. But again, I think we've had the wrong kind of management in very large varying degrees and still kind of insulated enough to do enough of an insulated bubble to focus on the areas that were most important, even if they didn't think those areas were important.
So Shea, you've had to take a whole bunch of bets on different tech directions over the years, obviously, right? And some of them go smashingly well, and some don't work out. Have you got any idea how to pick a winner mindset?
No, I wouldn't be sitting here, I guess. It would be someone else. No, I mean, it is that evidence kind of thing, like just pick two the main contenders at that time. Have a quick look at those. If you can't pick it based on the sales channel, again, that's a terrible way to pick a product, but pick the two main ones in that space that look like they're kind of aligned with where you're going. Try both. It's probably not enough of a spike to like go all in, but
So
kind of
I'm just one of the
typically
ones
do.
that feel
Yeah.
right, and then they turn out to be not right.
Yeah, and I guess that's that whole. You gotta stick with it long enough to learn enough to know why
Get the
not.
spidey sense. Yeah.
Because I
Typically,
guess
I found the ones that a big vendor throw a lot of kind of developer outreach evangelism at early on without success. They're the ones that are going to go horribly wrong. So when you've got, something comes out and the next minute you've got 30 different consultants giving the intro level talk at a conference about it, you go, and it's all, whenever the hard question is like, don't worry about that. They're the ones.
framework takes
yeah.
care of it.
Yeah,
There's a
they're-
button.
they're
There's a
the
button
ones-
for that.
Yeah, they're the ones that are going to get abandoned.
Yeah, so I guess having that sort of stages of learning thing where acknowledging and kind of realizing that I think I'm at the stage 4 boundary where if I keep pushing, like I'm probably at that point where it's just too hard. I just want to go back to the things I know. So I guess it's getting just enough past that to know why you'll never pick that thing ever again.
Anything that involves code generation.
Can't
I'll
think of
get
any-
Swagger in there eventually.
Code
Never!
There's some Alan K videos on that too.
When code's in.
How the internet is run. That's another interesting thing. Yeah, look, I guess it's just acknowledging, knowing where you are on the curve and kind of knowing enough at that stage 4 juncture of if you hit that wall, stick with it just long enough to know why and actually have pretty good evidence or measures as to, why that might not be the right choice. I mean, that's a really tough one to know where that point is where you haven't gone past that sunk cost fallacy point of just, I'm all in, I'm just going to write this stuff until it catches fire and we're all dead. But it's, it comes with experience, I guess, of knowing, like, I think I know and I can actually measure and quantify why I think this isn't a good idea now. If I was to get asked again, would you do that again? You're like, well, no, because these reasons. Having that level 4 to stage 4 to stage 5 knowledge of just why not. I think that's important to get past that initial gate, because you might get past that curve and realize that it is the right choice, but you now know how to hold it. Maybe you were holding it wrong to start with because you're trying to figure it out. Yeah, it's always been gut feel, and to try and put it in slides was really hard to find someone who's articulated it well. So hopefully there's something useful in terms of some words and techniques of like knowing when you're at that stage 3. I'm really excited. This is going to be my silver bullet. It's going to solve all my problems. I'm probably thinking of this in the small, and it might not scale to the large that I'm trying to implement it in. But having the mentors and the other people available who may have actually done that before. If you don't have them on your team, do everything you can to get access to one or someone who's done it before, even if all you can do is rubber duck, bounce ideas off them to say, hey, look, I'm about to go down this path. Where are the sharp and pointy bits? Please tell me how to dodge them.
Just on that, do you think is there a pattern to technologies that you think traditionally have a longer lifespan? Like you said before, your background is largely in Microsoft. I mean, is there a particular reason for that? Or I guess my question is like, some projects start out as community projects and they flame out pretty quickly.
Yeah.
Other ones go for decades.
Yeah.
And in recent years, you've seen like big tech companies outsource things that they're working on, like GraphQL and projects like that. And you sort of get a sense that kind of one of these types of origins of technologies leads to better longevity than others.
Yeah, in going through this exercise, I was trying to, when come up with the programming paradigm slide, and I realised how much time I'd spent in this little slice that was invented at the same time as all of these other different things. It's like, why did I spend so long there? And again, I started C# in like 2001. I don't think it's ever been bad enough to leave. Like, it's kind of got everything. Make everything work. Again, you usually might be working against the language, but once you learn the techniques and tools and strategies to do that, you kind of end up with this big toolkit of all those different things. I can make those work. Again, if you maybe take a step outside every now and then, do some learning, like as a team, just throw out a random, like, let's do some brown bags or study sessions on this other functional programming thing, just to see what it's all about. Maybe it's got some goodness. Try and take the things that you've been doing over there and go, that does it in like 3 lines of expressiveness that gives me all these guarantees and checks, and you're like, I can't stuff up like I do over here. Threading over here can get really complex, same as Java. Over here, it largely goes away. Why is that? But in terms of like which technologies and stuff kind of had good long-term things, anything messagey based felt like they got the best longevity. Like even like MSNQ, for all its warts and terribleness, the concept and what it kind of allowed you to break apart and decompose into this thing happened, put this in a queue over there for someone to process. It keeps coming back to that, we were programming against 1 core, 1 block of RAM, but then all of a sudden we had 10 machines. How could you leverage that 10 machines? In some programming languages and things, it's really hard to leverage all the cores on your 1 machine. You end up in that multi-threaded programming space on single core, and then you scale it out to 10 machines who've all got 10 cores. And then all of a sudden, your primitives in that language and the styles of the database and the way you access things don't really match that kind of physical breakup of your systems. And those kinds of queue-based things were really good at putting something out there for another process to leverage on. And those kinds of things come with their own challenges as well, like competing consumer kinds of things and concurrency and how you solve those kinds of problems. But those particular things felt like I'm still leveraging those today.
And were those traditionally sort of projects that started as open source, or were they vendor projects, or like I guess that was sort of the part I was interested in from your perspective.
Yeah, there was some stuff. It's like, we've got to process this large backlog of stuff. How can we efficiently distribute? I got to send 1,000 emails. How can I do that? And you're on 1 machine. I could batch pull down 10 at a time, and then try and multi-thread, spray that out onto the 10 cores on my machine, and then you're got another machine. How do you both fight over that workload of things to do? And you started looking around for solutions. You're at that sort of stage 2 where things are getting a bit hot, and you're it's just weird and hard to try and distribute this work across a cluster of machines, what's better ways of solving those kinds of problems, and start looking around for, there's this MSMQ thing built into Windows, again, being in that Windows stack, quite junior kind of time, it's like, that looks like it would do a job. Challenges ensued to trying to get past that stage 3, like, hey, solution to our problem, and you get that, trying to get the code, like, oh god, I just want to go back to the database, so it's easy to just do some of this stuff that I know how to do, and we fought past that kind of hurdle, and it yielded massive fruits in terms of better ways to distribute concurrent work. And kind of changed the thinking after that of, this is really good at this particular problem. And trying not to use that as a dogmatic way to solve all problems. That was the other challenge. There's no real one thing that stood out. Because I guess, ORMs came up and you're like, this is definitely the solution to the database. No one likes writing stored procs and writing code gen type stuff to talk to those stored props and map them back. Some little tools and frameworks started coming out with ORMs, and it kind of pushed a lot of that incidental complexity away. It was good for a while, and then all these new problems started arising with N+1 queries where it would lazily go back to the database and do all this other stuff, and then all the efficiency started creeping in, and that was now the new problem. And then a new framework could get designed to solve the N+1 problem, but no one really stood back and went, why are we persisting with this? Is there maybe a different way of doing it rather than just keep going, keep investing, keep changing, going down that path? Every now and then someone kind of pulls it back and goes, wait, what's going on here? Can't we just write an efficient query and execute that? Or are we trying to, But there's no real particular thing in general. Everything kind of changes over that time. It follows that same kind of trend where it's good for a while and then you realise what's wrong with it, so you'll start looking for another solution or a different way to tackle that problem. And then you try down that thing, and then you learn the trade-offs with that other thing, and you just learn a lot of trade-offs and where things don't work, essentially. So when the next problem comes up, you've got 8 different ways that you've done it in the past, you understand all the trade-offs, maybe there's a new one on the horizon, maybe it's better the devil you know, maybe we should trial that one, let's spike it maybe.
Each of those patterns come either from big vendors or open source and community, like messaging. There's both database frameworks, there's vendor supported ones and open source ones. It's more about the pattern.
Yeah, it solves the pattern at the time.
Yeah.
That needs a better solution.
Yeah, and where your customers are coming from.
Patterns have been pretty universal in terms of like, how do I take like that enterprise integrations patterns.com, whatever it is, the Martin Fowler-ish website. I don't remember who writes that down. That's really good in terms of just generic problem domain things. How do I take this one thing in and distribute it to 10 things? And so, well, we could use our own database query queuing thing for that. We could use a broker product for that. There's like lots of different ways to solve that, but it tried to take it back to everything's core challenges that you have. Like, I've got this particular problem. You try and find where it matches that, and it really articulates that problem well, and you can try and look for products or tools or languages that might match that particular problem space well. Nothing really stand out though. Nothing that's ever really stood the test of time since, 16 years ago. There's not many things from 16 years ago that are still kind of prevalent now, other than procedurally block kind of step 1, step 2, step 3, step 4. It just kind of gets spread between classes and methods, but it's essentially still the same way that we've been doing stuff for 70 years. It hasn't really changed much. But again, that's the whole, maybe we should jump out, check out a new paradigm for that kind of stuff. Maybe there's better things for that expressiveness and concurrent type of things that better match our hardware now. Don't stay in a safe place. Spread chat every now and then. Try something different. Might be. There is no answer. All the answers are wrong. Yeah, I'd like to keep this conversation going in terms of next user groups, other different things. Find out if other people have tried a different thing. It's great in the workplace to do brown bags, pick a problem, put aside an hour and try and solve it with something just completely different that might better represent or match that particular problem at hand. And, try different things. It'll expand your thinking. Go in that growth mindset of maybe there is a better way to do this stuff because it's not a solved problem yet. We don't have all the answers yet. Keep learning.
Thank you so much. Cool, let's go home. Thanks, Shay. I know I've been bothering you for a very long time to
Good.
sober and not sober. So
Both of us.
so that is the last event of the year. Thanks again, Shay. That was an awesome talk. If you want to run another follow-up one next year, that'd be great.
Yep.
We did schedule you accidentally for the next 4 years. To
Done. I'll come back and ask what everyone's been doing that's outside their comfort zone every week.
Therapy with Shea.